Now let's do an example friction problem. Let's say we have a mass that we know is sitting on a desk, so a flat horizontal surface, and this mass is 10 kilograms. We're told that the coefficient of static friction is 0.500, and the coefficient of kinetic friction is 0.350. Remember, static friction means the object is at rest, and if we want to move the object, we have to overcome the force of static friction to do so. However, if the object is already in motion, then we are concerned with kinetic friction. Now in this problem, we're told we have an applied force of 37.0 newtons. The first question that I'm going to ask is, will this mass accelerate? In other words, will it move if it's starting from rest? That's the question I want to know. Again, I have to start with a free body diagram. I know it's sitting on a desk, and I know that we have an applied force, and I know that since we're on the Earth, there is a force due to gravity. In this case, because I know that that applied force is what would cause motion to start, I know that the force of friction must be in the opposite direction. So if we're starting from rest, in order to get this object to move, the magnitude of our applied force must be greater than the magnitude of the force of friction. In this case, the force of static friction. If this is true, then yes, our object will accelerate. We know that the equation to find the force of friction is the coefficient of friction times the normal force. In this case, we need to solve for a normal force. To do so, we're going to take a look at our y direction. We know in the y direction that the net force is 0 newtons because the object is sitting on a desk. We also know the only two forces are the normal force and the force due to gravity. In this scenario, that means the normal force and the force due to gravity are going to have equal magnitudes in opposite directions. We also know that we have an expression for the force due to gravity, which is mass times the acceleration due to gravity. Remember, the acceleration does not cause the force causes the acceleration. So now we're simply going to plug in our values of 10.0 kilograms and 9.81 meters per second squared. Since I made the acceleration due to gravity positive, meaning down is positive, we're going to find our normal force is negative. Remember, this just means opposite direction in physics. So if 9.81 meters per second squared was down, and it was positive, negative 98.1 newtons will be up. Now I have to solve for the frictional force. And now I'm just going to plug in my equation, the coefficient of static friction times our normal force. The coefficient of static friction was given to us as 0.500. And now we know our normal force is 98.1 newtons up. Remember, in this equation, it lies to us. It makes us think that signs are important. But this equation cannot tell us direction. The only thing it can tell us is magnitude. So I'm always just going to use positive values, and it's going to be up to me to figure out which direction friction is going to act. And we're always going to figure that out based on motion. When I plug in my values, I find that I get 49.05, but because we are dealing with significant figures, I'm going to get 49.1 newtons, and that's going to be my value of static friction. In this case, that 49.1 newtons is greater than our applied force. Because friction cannot cause motion, this object will not move. And the net force on the object will be 0 newtons.